Kazoo, it's time for the week 5 check-in. Come here, sweet pea. Come here. We have a lot to talk about. First off, can you see that? Thank you so much for your work. It has been hard. A lot of practice necessary, and I want to share with you how far you've gotten. I'm doing a SAT prep, and look at some of the questions that I found. Here's one. It's a similar triangles, and then you're finding the cosine of E. You don't know how to do that yet, but you will by the end of this week. Another one that I wanted to share with you, well, another piece here. There's some reference that you always get when you're taking the SAT. We'll get into these special right triangles this week, and volume of some 3D solids. And the one I wanted to share was, I think, here's one. What is the value of B plus C? That one's not so bad. Take a look at this one. You've got a quadrilateral. Let's fix that corner. Two parallel lines. What is the measurement of angle B? I don't think you're able to do that one, but again, by the end of this week, you will be, because Module 6 is right triangle trig, and you'll actually be accessing those sine, cosine, tangent, those keys on the calculator that you've seen a lot but may not know about. We're doing trigonometry. I wanted to share with you, let's see, I'm looking at my agenda here. So Module 6 is triangle, right triangle trig. I think in this whole week, there's only one proof. That's awesome, but there are also some things that might give you some difficulty because we're getting into a little bit more of algebra stuff. So can you do any of these? Can you simplify 2 radical 3 squared? Can you simplify the square root of 50 and rationalize 8 over the square root of 2? Pause me now, see if you can do it. Pause me, really. Pause, do it. Okay, first one, 2 radical 3 squared should be, that's the square root of 12. The square root of 50 can be, that's the square root of 25 times 2, that's 5 root 2. And then 8 over the square root of 2. Mathematicians typically don't like to have irrational numbers in the denominator because we know what it means to divide by 3, divide by 4, but to divide by a square root, we just change 8 radical 2 into, that would be 4 root 2. So if you flew through those, wonderful. You've got some algebra underpinnings that are pretty solid. If not, those are the kind of things that you may want to check in with me on or ask for me to make a video on some of these, because when we get into right triangle trig, those are the kind of relationships that you'll need to know. And there's a little bit more algebra involved. Office hours this week, I will post. My daughter's going to a camp, a socially distant camp, but one that is just like a 9 to 3 on my time. So I'll post office hours, but there will always be maybe a little bit of squishy time where I might have to go and get her or leave her off or get her. I will always put on Twist when I'm leaving, when I'm coming back. But those office hours will be around the same as before. If you are having trouble making them, let me know early on so we can set up something so that it doesn't get to Thursday or Friday and you can't check in. You want that low-hanging fruit. And it's also okay to check in with other people on Twist, for sure. Here is the world. Now, what we've been doing in geometry is mostly 2-dimensional stuff, and it's wonderful. It's great for a foundational piece in problem solving, but when it comes to in the big, real world like this, parallel lines don't actually meet. Euclid, in his Elements, put out 5 different postulates. Mr. Steiner told you about some of them at the early on, like between 2 points, there's exactly 1 line. For every 1 line and 1 point above it or below it, you can make 1 parallel line. And the 5th postulate is one that was kind of iffy, that not everybody always agreed on, but they couldn't prove it or disprove it. It was that parallel lines essentially don't meet. But take a look at the latitude lines here going upward. Or sorry, these are longitude lines. Lat is flat, but longitude lines, parallel lines, they actually do meet in a three-dimensional non-Euclidean geometry, as well as, this will blow your mind, say you take a triangle in just a swath of the north, this globe, and take a triangle of it, angles actually add up to more than 180. I hope you're okay with that. That sometimes, just like relativity, in the world that we live in here, most of the time things are flat. And when we say one time, it's not relative to somebody else. One time to us is one time to them. But sometimes the rules, as you learn a little bit more, get a little bit stranger. So, okay, be ready for some extra credit options this week. It's time to kind of mix things up a little bit. I know you okay, but I'd like to maybe see if you can write a song, maybe some poetry, maybe I'll throw in a question, maybe prove it, or something that's a little different, just to give you some incentive to stay with us and know that we are 4 down and just 3 to go. So I'm so proud of you and can't wait to see you this week. And be well, try to get outside. Oh, Kazoo, you want to say bye? And be kind to everybody. Right, sweetie? All right. Take care.